Hello there, welcome to this video on verifying trigonometric identities. What we're going to go ahead and do is split this video up about halfway through. This is a 2-day lesson, so by no means you should try to power through this. This is a pretty complex lesson, and you're going to have to use your brain in critical thinking ways. So just be prepared for maybe your brain to hurt after this one. Again, you're going to need knowledge of flashcards utilizing your Pythagorean identities. We're going to use the Pythagorean identities, like I said, the quotient identities, and reciprocal identities. So what are we doing in verifying trigonometric identities? Well, the identities allow us to rewrite trigonometric equations that model real-life situations so we can use our algebra skills to solve problems. And the key to verifying identities and to solving trigonometric equations is being able to just kind of substitute in, right, swap out things that are equivalent, okay? Now, I want to talk about a conditional equation, and a conditional equation is true only for some values and of the domain of a variable. So for instance, something like this, like x squared minus 6 equals 10. Well, that's true for only positive and negative 4. And then same if I had a linear equation, 3x plus 5 equals 14. Well, this is a conditional equation because 3 is the only value, right, that works. I can't plug it in for anything. Well, an identity is true for all values of the domain variable, okay? So it's equivalent no matter what. And some examples here are 5x minus 2 is equal to 5x minus 2. Doesn't matter what I plug in for x, that's always, always, always true. Same with the Pythagorean identities. Sine squared theta equals 1 minus cosine squared theta. That's true for all real numbers theta, okay? And then same for tan theta is equal to sine theta over cosine theta. I think you get it. All right, so there's no well-defined set of rules to follow in verifying trigonometric identities, and it's kind of just best learned through practice, trial and error, and experience, okay? So when you verify an identity, you can't assume that the two sides of the equation are equal because you are trying to verify that they're equal. So therefore, when you're verifying identities, you cannot use algebraic procedures such as adding to both sides or multiplying both sides by a certain equation. Just meaning like I can't assume, right, that they're equivalent. I have to prove it. That's what you're trying to do, okay? So here are some general strategies that we're going to implement. And number one says work with one side of the equation at a time. It's often better to work with a more complicated side first, and that's generally because I can go ahead and kind of break it down, simplify it, make things collapse to look like the simpler side. Step two, look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. Okay, and so these are some of the strategies that we'll use in today's lesson. Step three, look for opportunities to use the fundamental identities. Note which functions are in the final expression you want. Sines and cosines pair up as well, as do secants and tangents, and cotangents and cosecants. Okay, so just again, those flashcards, if you've been working with those flashcards, that really helps. When the preceding strategies don't help, try converting all items to sine and cosine. And that's, I would say, the most effective method. Okay, step five, always try something. Even making an attempt that leads to a dead end can prove some insight. Throw the kitchen sink at the wall, okay? And sometimes you get lucky. All right, so let's go ahead and look at this example. So we are going to verify, and we're asked to work with the more complicated side first. Okay, so let me pull up my pen here. Where's my pen? There it is. Okay, so what you should see here is I have secant squared theta minus 1 over secant squared. Okay, and one trick that I want you to be able to see is if I have multiple terms in a numerator over a denominator, what I can do is I can go ahead and kind of split these. So I have secant squared theta over secant squared theta minus 1 over secant squared theta. And maybe you're saying, hey, is that legal? I will make it legal. Yeah, it's totally legal. I imagine if I put them back together, they have the same denominator, common denominator. So can't I go ahead and combine those fractions? Yes. Okay, so totally legal and viable. I can do this. And why is this so effective? Well, what's secant squared divided by secant squared? 1. What is 1 over secant squared? Cosine squared. I don't know why I'm singing in a sing-song voice. You know you have the captions on and someone does that and says, in a sing-song voice. I wonder if that works for me right now. Okay, and 1 minus cosine squared. Well, this is a Pythagorean identity. This is sine squared theta. Hey, isn't that what we wanted? Which was sine squared theta? Oh, you betcha, right? And then here's kind of a cool thing in mathematics we do. We put a little box at the end of our verification. And this is Latin QED. I don't know exactly what it means in Latin. I would embarrass myself if I tried to say it. Google it, QED, okay? It's Latin, and it pretty much means, hey, I showed it. I did it. Yeah, that's me. I did it. Okay, so that's one method, right? Another method that we can go ahead and do, which I'll go ahead and do over here in green, is I can start outright with a Pythagorean identity, okay? And if we have secant squared theta, okay, again with our Pythagorean theorem identities, this is 1 plus tan squared theta. Okay, and if you don't believe me, you can go back and check in your notes. You should have all the identities. So what I'm going to do right now is I'm just going to substitute. So I'll say that this is equal to tan squared theta plus 1, right, minus 1, all over secant squared theta. Okay, well, my 1's, they cancel, right? So now we have tan squared theta over secant squared theta. Okay, and kind of a trick is to just go ahead and separate these. So if I separate it like this, this is tan squared theta times 1 over secant squared theta. Okay, here's where switching to sine and cosine really, really helps. So what's tan theta? Well, isn't that sine theta? So since it's tan squared, it's going to be sine squared over cosine squared. Okay, times, and then secant squared theta. Well, isn't secant squared theta cosine squared theta, right? That's just a reciprocal identity. And then, hey, check it out now. Old school funk, right? So I get those cancel. Do you guys even know that song? Old school funk, check it out now. Okay, sine squared theta, hey, boom, QED. I did it. Done. Okay, and we have just verified. That's verifying, right? So again, you're just swapping out. This is equal to this. This is equal to this. This is equal to this. And really, a lot of it comes from like recall, your memory. Okay, being able to memorize those stuff. Okay, so flashcards. 5 minutes a day. I want you to put it in your phone. Like, you know what time you go to bed? 5 minutes before you go to bed. It'll help you fall asleep. Because although math is interesting, sometimes it can make you sleepy. Please go ahead. Pause the video. I want you to try this one. All right, so hopefully you have paused the video. I want to point out, I hope right off the bat in the numerator, I hope you saw a Pythagorean identity, sine squared plus cosine squared, right? So that is 1. Okay, this gives us 1 over cosine squared theta, secant squared theta, okay? Which is equal to, and I don't know if you knew we could do this, cosine squared theta times 1 over secant squared theta. So if you got stuck and you didn't know, pause the video. I want you to clean it up now. You should be able to easily do this. All right, so hopefully you did this, and I hope you got this, right? So secant squared theta, that's just cosine squared theta. Sorry, 1 over secant squared is cosine squared theta. All right, let's look at this example. Oh, you know they're getting tricky when they start throwing in alphas and betas. I don't know if you're familiar with this symbol here. This is alpha. Okay, a Greek letter, alpha. lowercase a, pretty sure, lowercase a, alpha. This is alpha, right? And it's just a substitute for theta. And yeah, I hope you noticed they've been using x's, they've been using thetas, they just switch it out. It's just a variable, right? They're just getting kind of kooky with this. All right, kooky. Who says kooky? Okay, I'm getting kooky. All right, we're going to go ahead and verify this. And they give us a strategy. They say combine fractions. And I hope, here's like cues. This is mathematics, like recognizing stuff. I hope when you see those, I hope your brain is just shouting this. Conjugates, conjugates, right? They are like essentially like opposites. So here they tell us, hey, combine fractions. So let me rewrite this. Conjugates. It always makes me think of Conjure Club. It's a Star Wars reference, by the way. Okay. So what we're going to do, in order to add these, I need them to be the same. So here's what we do. We multiply by the conjugate. And multiply by 1 plus sine alpha over 1 plus sine alpha. Over here, I'm going to multiply by 1 minus sine alpha. 1 minus sine alpha. Okay, so how does this help us? Well, in the numerator, I get 1 plus sine of alpha. Okay, over, so 1 times 1 gives me 1. 1 times negative sine theta and sine theta times 1, those will cancel out, right? They're opposites. That's kind of why we do this. And then sine theta times sine theta gives us sine squared alpha. Okay, so I have that. Plus, now on my right side, we get 1 minus sine alpha. Okay, over the same thing in the denominator. 1 minus sine squared alpha. Okay, so I hope you see that we can go ahead and combine. So I have 1 plus sine alpha in my numerator, plus 1 minus sine alpha, all over 1 minus sine squared alpha. Okay. All right. So this is why we start with more complicated side. Notice I have sine alpha. Boom, that cancels. Negative sine alpha, right? So those go away. And then all of a sudden this becomes 2 over 1 minus sine squared alpha. And at this point, I hope you are thinking Pythagorean identity. Okay, and that is cosine squared alpha will be equal to 1 minus sine squared alpha. So I'm just going to substitute this. This is 2 over cosine squared alpha. All right. Okay, what do we want to verify? Like, I forget sometimes. You have to go back. What are we even trying to do? I want 2 secant squared alpha. Oh, okay. Well, this is 2 times 1 over cosine squared alpha, right? So isn't 1 over cosine secant squared? Heck yeah, 2 secant squared alpha. And we're done. Right, QED. Boom! I showed it. Okay. All right, here is a practice problem. Please pause the video. Try this one. Same idea, right? Oh, new symbol. Hey, this is beta. Beta, another Greek letter. Beta fish. Beta fish, right? Okay. Sorry for being lame. All right, hopefully you tried this. I hope you multiplied by the conjugates. And it's a really very similar structure. So here is the solution. All right, I have one more example that I want to show you, and here it is. We are asked to verify the identity, and here it says use identities prior to multiplication. Okay, so in this one is pretty tricky. So what we'll do, they tell us to activate our identities. I see tan squared plus 1. I know that this is secant squared theta. Okay, so secant squared x. All right, and cosine squared x minus 1. This one here, I'm gonna go ahead and kind of pull something funny on you. I have cosine squared x minus 1. Now, if I wanted to use Pythagorean identity, sine squared x is equal to 1 minus cosine squared x. So what we're going to do in order to get it to look like this is I'm going to factor out a negative 1. Okay, and here's what I do. So I'm going to take out a negative, and it changes the sign. The 1 now becomes positive, and my cosine squared becomes negative. Okay, now why in the heck, and be careful, that's not a I'm not doing subtraction, right? This is multiplying by a negative, one of these. Okay, and I'm doing this because now I have secant squared x times negative sine squared x. So I make that substitution. Okay, so why did I do that? Well, secant squared, that is 1 over cosine squared x, okay, times a negative sine squared x over 1, which happens to be, if I combine them, sine squared x over cosine squared x. And sine over cosine is what? Tangent squared x, right? And it is negative. And we did show what we wanted to show. There it is. Okay, so yeah, this one was pretty tricky. That one was tricky there. All right, here is a practice problem. Go ahead and try this one. All right, hopefully you've tried this. I hope you see that negative out front, and that negative out front, right, kind of tells you that you need to produce a negative somewhere. So maybe, like, this is your hint, right, that you need to switch this around, to pull out a negative. Okay, and so if you do that, you get cosine squared with the negative, and here we switched out secant squared x minus 1 for tan squared x. Okay, and again, this is coming from the Pythagorean identity, right, that tan squared x plus 1 is secant squared x. We just kind of manipulated it, right? Subtracted 1 on each side. Okay. Hey, that does it for this video. I hope your brain doesn't hurt too much. Hit those flashcards. Keep trying. The next video on this lesson will do more of this, even more. Okay? So, catch you next time. Peace out.